Ever wonder how AI chatbots or virtual assistants learn to sound human? It's not magic, it's a tricky science called language model alignment. But here's the thing. When AI gets confused by messy or unclear data, it can start giving weird or even harmful answers. Today, we're diving into a game-changing breakthrough that's making AI safer, smarter, and more reliable. Let's break it down. Imagine you're teaching a model to pick the best answer to a question. You give it pairs of responses like, should I hike or drink alcohol to relax? And the model learns which one humans prefer. But what if the data is noisy? What if some answers are clearly better, while others are ambiguous? That's where this research steps in. Most AI training methods treat all data equally. But not all preferences are created equal. Some answers are obviously better, like hiking over drinking, while others are a toss-up. Traditional methods struggle when the data is unclear, leading to models that overfit to confusing signals. It's like trying to learn math from a teacher who sometimes gives conflicting examples. Your brain gets stuck. Enter g-SimPO, a clever new approach that acts like a smart filter. Instead of blindly following every piece of data, g-SimPO looks at how confident the model is in each preference pair. Think of it as a teacher who knows when to double down on clear lessons and when to pause and clarify confusing ones. Here is how it works. g-SimPO adjusts the reward margins for each pair of responses. A reward margin is just a measure of how much better one answer is than another. For clear, high-confidence pairs, like the hiking example, it boosts the margin, giving the model a stronger signal to learn from. For ambiguous pairs, like the alcohol example, it softens the margin, avoiding overconfidence in shaky data. This dynamic adjustment is key. Unlike older methods that use a one-size-fits-all approach, g-SimPO adapts in real time. It's like giving the model a built-in confidence meter that guides its learning process. The results? In tests across major AI models, g-SimPO improved performance by an average of 4%, a big deal in the AI world. It's not just faster or cheaper to train, it's more robust. And here's the kicker. It requires minimal code changes to implement. You could plug it into existing systems without a major overhaul. Why does this matter? As AI becomes more integrated into our lives, whether in healthcare, education, or customer service, we need models that are reliable and safe. g-SimPO is a step toward ensuring AI aligns with human values, even when the data is messy. But g-SimPO isn't the only breakthrough. Let's shift gears and talk about how AI learns from feedback. Imagine training a robot to walk. You don't just say walk once, you adjust its movement step by step, correcting mistakes as you go. That's basically what AI researchers are doing with language models. These models start as blank slates, generating text based on patterns in data. But to make them reliable, like stopping them from spouting nonsense or being rude, we need a way to teach them what's good versus what's bad. Enter preference optimization, the AI equivalent of a teacher grading essays. Researchers show models pairs of responses, one that's good, one that's bad, and let the model learn the difference. But here's the catch. How do you turn human feedback into a math problem a machine can solve? That's where techniques like rDPO, IPO, and their newer siblings come in. Take rDPO, for example. It's like giving the model a scorecard. Every time it generates a response, the system checks it against human preferences and adjusts its answers. But rDPO has limits. Think of it as a basic training wheel. That's where rDPO steps in. This method uses a clever math trick called a loss function to nudge the model toward better behavior, like a coach, adjusting a player's form in real time. What makes rDPO special? It's designed to be more efficient. Traditional methods might require massive datasets or super-specific settings, but rDPO simplifies things. By tweaking a parameter called epsilon, think of it as a smoothing factor. The model learns faster and avoids errors. It's like giving the AI a shortcut to understanding what we want. Now let's talk about a game changer, γ-SimPO. This method takes the idea of feedback and cranks it up. Researchers tested it on datasets where humans rated model responses, like a teacher grading essays. By analyzing what earns high marks, the model adjusts its answers smarter. In experiments, γ-SimPO outperformed older techniques by up to 1.4% on complex tasks, a tiny number but huge in AI terms. Here's how it works. Imagine the model is a student and a reward model is the teacher. The policy model, the student, tries to write essays and the teacher gives grades. γ-SimPO adds a fine-tuning knob, letting the model adjust its approach more precisely. It's like giving the student a rubric that evolves as they learn. So next time you chat with an AI, remember, behind the scenes, researchers are working hard to make sure it's not just smart but wise. From g-SimPO confidence-based filtering to γ-SimPO's adaptive feedback loops, these innovations are shaping the future of AI. Stay curious, keep learning, and let's continue pushing the boundaries of what machines can understand. Thanks for watching. If you want to dive deeper into the math or see how these techniques are applied in real-world systems, hit that subscribe button and let me know in the comments. The next frontier of AI is just getting started, and we're all in this together.